Hello, this is Mr. McGovern and welcome back to the sixth video in the Projectile Motion series. We're looking at a calculation here where we're putting all these ideas together. So this is a cannon which is shot at an angle of 30 degrees at 60 meters a second, and we want to find out how far horizontally this cannonball goes. Some tips we're going to add in here is, one tip is we're going to find the time it takes from the cannon to get to the highest point. And the reason we do this is because we get an extra bit of information out, and that information is at the highest point its vertical velocity, not its full velocity, but its vertical velocity is 0. So that's just a little bit of extra information we can use to put into our formulas and solve. Once we know that time to the top, then we double it to find the total time, and the reason is that these projectiles, if we're going from the same height to the same height, they're symmetrical. Now my diagram doesn't look quite symmetrical there, but that's just because I've just made a cheap PowerPoint diagram. Alright, the plan is very similar to last time. We've got some extra little steps thrown in, but we're going to start again with motion maps, but then we're going to do velocity components because we're not starting off with just a horizontal velocity. Then we do our table, really important. We set a table up with the horizontal and vertical values. We find the time to the top of the motion, like I said before. And then we double that, and then that's the same for both parts of the table, both the horizontal and the vertical, and then we can find that distance. So motion maps first. I want to think about horizontal first. We know horizontal motion is the same velocity every split second, and I've called my right positive, and my velocities are all positive. The vertical velocities are, it's going up and it's coming down, so I'm going to call up positive. So I've got my ball on its way up towards the top of the motion, is that velocity is positive, and then it falls back down again, and the velocity increases on the way down. So on the way down, its velocity is negative. Now on the way up, its acceleration, which is change in velocity, is down, so that's negative. And on the way down, it speeds up, so its acceleration is still negative. So we're going to be using acceleration equals negative 9.8 for this one here. Okay, components first. So I've got 60 meters a second with a 30-degree angle. So same as before, got my SOCAR toa, and I'm using sine opposite over hypotenuse. That will give me the hypotenuse is my 60, and my opposite is my Vy, which is my vertical, and rearrange that, and I get 30 meters a second. So 30 times sine 60 is 30 meters a second. I can do the same with the adjacent hypotenuse, which is cos, which is going to give me my horizontal, my Vx. It's my initial speed of my horizontal. Put those together and I get 52 meters a second. So those don't add up to 60. Some people think they should. In a triangle, obviously, if I went 30 squared plus 52 squared, I should get 60 squared, not just 30 plus 52 equals 60. Alright, so now I've got some initial speeds. I can set my table up. So again, I like to have written that horizontal motion is constant velocity and vertical motion is acceleration, so I remember all the information that I need. So in my horizontal velocity that I'd worked out before was 52 meters a second. I don't know the time or the distance it goes for. My vertical motion, and I'm starting with my acceleration, negative 9.8. Now I've left the motion map on the left hand side there, so you can see that I've chosen up to be positive, which means my acceleration is negative. My initial velocity that I found from my components is 30 meters a second, and that's positive because you can see my initial velocities are going in the upwards direction. And my final velocity I don't know, my time I don't know, and my distance that I go up and down in my vertical I don't know. Alright, so the time to the top. The trick we've got here, and I've got it in bold, is that the final velocity in the vertical component when we get to the top is 0. So now I've got 3 bits of information, and I want to find a fourth. I can find an equation of motion, and that equation of motion is the one that I've got there. Vf equals Vi plus At. To find my time to the top, put my numbers in. Initial was 30 plus negative 9.8. I'd subtract 30 onto the other side and then divide by negative 9.8. I've got 2 negatives now. They cancel out. I get time equals positive 3.1. So that's the time to the top. The total time is going to be double that, so 3.1, and the total time is going to be 6.2. So now I've got the time that the full time it's in the air for. I can now use my horizontal velocity. I've got the full time it's in the air. Horizontal motion is constant velocity, so I can use the constant velocity equation, and we get distance is just velocity times time, 52 meters a second times 6.2 seconds, which gives me 322 meters. Now that is quite a few steps, and once again, in physics, what you find is, if you look at the whole picture, it looks difficult, but I'm sure you can handle each step individually. So it's about practicing, making sure you're not jumping any steps. That's where you make mistakes, when you try and do a couple of steps in your head. My tips for this whole process are motion maps. Set your motion maps up first, both horizontal and vertical. They help you remember that horizontal is at a constant speed and your vertical motion is got acceleration, and they help you set up the positives and negatives, especially for the vertical, correctly. So katoa, I kind of, when I was doing my components, jumped that, but normally in an exam I'd write down so katoa before I worked out my components. The table, so many people, students that I've had, use the table in practice, but when they get to an exam they just completely ignore it again. It's so useful to make sure you're not mixing information between the vertical and the horizontal, and getting this idea of constant and acceleration models for either horizontal or vertical is so important as well. So the table is so useful, and I really encourage you to use it. The time to the top is obviously something useful that you can calculate, and once you've got that, then you can double it to get the total. So that's the end. I'll come back at some stage and I'll find an exam question and we'll run through that for projectile motion.